In this video, we're going to talk about graphing quadratics. And as you've noticed so far, quadratics are things that look like ax squared plus bx plus c equals a number. Well, if we're going to graph things, then that means we need things on the x and the y-axis. So in this formula, we already have spaces for, meant to highlight. We already have spaces for x. So now we need to add some spaces for y, and where the y is going to go in this formula is here. The y is going to go on the right side of the equation for graphing quadratics. So let's change out this number symbol and let's put the letter y. So anytime you have ax squared plus bx plus c equals y, anytime you have anything where x is squared and you want to graph it, you set it equal to y, and then you just make a table. This one is the easiest quadratic. So because it's the easiest, because it's the most basic, the most simple, we call that the parent function. And I'm going to move this because that's in the way of that graph that I have. Whoops. There we go. So the easiest quadratic is a parent function. To graph this, it's just like we did with the linear functions, and that's you make a t-chart of x's and y's. You get to pick the x's. Let's try 0, 1, 2, and see what happens. So y is equal to x squared. So then for this one, we're going to do 0 squared, which is equal to 0. 1 squared is equal to 1. 2 squared is equal to 4. So then our coordinates are 0, 0, 1, 1, 2, 4. So we're going to put those points. 0, 0, 1, 1, and 2, 4. Before we connect those, well, we can already tell that obviously this isn't linear. You look at that line, it doesn't touch all the points. Maybe you want a line of best fit, and it's going to go halfway in between all those. To know whether this is linear or not, you need to add more points. So we're going to put some negative points. Let's put -1, let's put -2 and -3. And let's go ahead and add +3. Then we're going to plug those in. So -1 squared equals 1. -2 squared. Oh, make sure you put these negatives in parentheses. We're not doing 1 squared and then making a negative. We are in parentheses -1 and then squaring that. -2 and then squaring that. So -2 parentheses squared is 4. -3 in parentheses squared is 9. And +3 squared is 9. So that means that my coordinates are -1, 1, -2, 4, -3, 9, and 3, 9. So now the ones we need to add are -1 goes with 1, -2 goes with 4, so -1, -2, we're counting by ones. We're at the origin there in the middle. And I only have space to do 3 on the right side, so I'm only going to put it on the right side. Well, let's count. I'm supposed to count up to 9. Let's see if it fits. 1, 2, 3, 4, 5, 6, 7, 8. I'll just make it up. So 3 would go somewhere up here, and -3 would go somewhere up here. If you're copying this down, you should probably have some graph paper or just be really good at making scales. But the only way you get good at visualizing things with a set scale is by practicing on graph paper first until you can like memorize the grid lines spacing in your head. So let's label these coordinates 0, 0, negative 1, 1, negative 2, 4, negative 3, 9, 1, 1, 2, 4, 3, 9. Something that you might be able to tell already that's in common is the y's are the same. The y's are the same on the left side and on the right side. We have negative 1 on the left, we have positive 1 on the left, positive 1 on the right, positive 4 on the left, positive 4 on the right, positive 9 on the left, positive 9 on the right. So what that means is in this example, through the origin is, last year you called this a mirror line, but in algebra, this is called the axis of symmetry. And for the axis of symmetry, for y equals x squared, is the line y equals, not y, x equals 0. It's a vertical line through the origin, and if it's going through the origin, this mirror line, if that mirror line's going through the origin, then it's a vertical line, and its x equals 0 is that vertical line. So that's called the axis of symmetry. That's just showing you that for a quadratic, you're going to have a curve going leftwards and a curve going rightwards. It's as you get more advanced in math, it'll be more important that you draw a curve, and I'll be able to help you with the next example. I'll do a zoomed in picture of this one. So for graph number 2, we're still going to do y equals x squared, but this time we're going to change the numbers that we pick for x. Instead of picking whole number integers, we're going to do some fractions. So we'll do 0, we'll do 1/4, we'll do 1/2, we'll do 3/4, and then we'll do 1. So we'll do 0 squared equals 0. We're plugging these numbers in for x above. 1/4 squared equals 1/16. 1/2 squared equals 1/4. 3/4 squared equals 9/16. And 1 squared equals 1. So that was us plugging in for x and then squaring it. So then the coordinates for y are 0, 1/16, 1/4, 9/16, and 1. So what that means is that we need to graph 0, 0. Let's go ahead and draw this graph. I'll make it the same scale as the last one. So if this is 1 and this is 1, then 0, 0 is our first point. 1/4 for x. So if we cut x in half, that'd be a half. If we cut a half in half, that's a fourth. 1/4 for x. And we're going to do the same thing for y. We cut it into fourths right now. And then if we cut a fourth in half, that's going to give us eighths, and then if we cut an eighth in half, that's going to give us a 16th. So 1/4 for x goes with 1/16 for y. 1/2 for x goes with 1/4 for y. 3/4 for x goes with 9/16. So right here was 3/4. 3/4 would be 12/16. Down here is 1/2. Right here is 1/2, which would be 8/16. So we're just going to go barely above 1/2. Right there. And then our last point was 1, 1. This was 1, 1. Here was 3/4, 9/16. Here is 1/2, 1/4. And then down here was, I'll put it below, 1/4, 1/16. Let's connect these. And then zoom out. And we can see that, yes, if I connect those dots, those are obviously a curve. And if we put even more points, it would make a smoother curve than what we have. So the more points that you put in your table, the smoother your curve will be when you're graphing a quadratic. And we can see that my earlier graph was a bit straight for this first section. That's kind of straight, whenever it should have been more curved at the start. But that's okay. These are just quick sketches. So those are two sketches of the parent function of a quadratic.